Hello guys, my name is Liad. Today I'm going to discuss a problem C Okabe and Boxes from Codeforces Round for 20 Div.2. This is rated for 1500. You can see the problem says that Okabe, being a control freak, gives Daru two n commands. So you are given two n commands, n of which are to add a box to the top of the stack, and n of which are remove a box from the top of the stack and throw it in the trash. Okay. Okabe wants Daru to throw away the boxes in the order from 1 to n. So you have to throw away the boxes in such a way that the order will be from 1 to 1. Okay. So of course this means that it might be impossible some cases in for Daru to perform some of Okabe's remove commands because the required box is not on the top of the stack, right? If you have to remove the box number X, there might be in some case when the required box is not on the top of the stack, then you can't do this, right? So that's why Daru can decide to wait until Okabe looks away and then reorder the boxes in the stack in any way he wants. You have an opportunity that you can reorder the boxes in the stack in any way you want, so you can do it between any two commands, that he can do it any point of time between Okabe's commands. So in between any two commands, you can reorder the stack in any way, in any number of times you want. Between, if you do this between any two commands, it will be counted as one. Okay. So the task is you have to do the operations, this reorder operation, minimum number of times that the removal operation he can successfully complete of all the Okabe's commands. Okay. So that it is guaranteed that every box is added before it is required to remove. So if you have to remove the box number 2, then it is guaranteed the box number 2 is added before. Okay, you don't need to worry about this. And it is also guaranteed that is exactly n lines contain add operations and all the boxes added are distinct. N lines contain remove operations, so n lines will be add operation and n lines will be remove operations and all the boxes will be distinct. Okay, so we have to print the minimum number of times that the Daru needs to reorder the boxes. Okay, so what will be the approach to do this problem? Suppose this is a stack, we have some operations. Suppose firstly we have operations at 3, then we have operations 2 at, then we have operations suppose 1. Okay, so then you have to remove a box from the stack. So in this case the top of the stack is 1 and you are removing at the first time, right? So you don't need to reorder in this case. Alright, okay, because the top of the stack is 1. Okay, so you can remove this from the stack, then it will be removed from the stack, then the top value will be 2. Then if any remove operation comes, then you can remove the top value from the stack again, because this is the number 2 remove operation, so the box will be number 2, the top of the stack is also number 2, so you don't need to reorder in this time again. So in the third time you don't need to reorder again. So if you have this type of command, so you don't need to reorder. But suppose that you have commands such as firstly 4, then suppose 2 at, then suppose at 3, then suppose at 1. Now you are given remove operation. Now at the top of the stack you are given 1, so first time you don't need to reorder, you can simply remove it from the stack. Then you have again a remove operation. So this time the top of the stack contains 3, right? But the number of remove operation you are doing is 2. So this is not the case. You can reorder this stack in any way you want. So what will be the reordering process? what will be the best reordering process that you can do, that if any remove operation will come again, then the top of the stack will be as the same of the box number. So you can do this by sorting this in increasing order, right? You can reorder this in such a way that 2 will be at the top, then 3 will be in this position, then 4 will be in this position, right? So then if the remove operation comes, you will remove 2, then you will remove 3, then you will remove 4. You don't need any reorder operation, right? So this is the best way to reorder this. Suppose we have this type of commands. Suppose we need to add, suppose 5, then we need to add 3, then we need to add 1, then we need to add 4. Okay, then now the you have to remove a box from the stack, but in this case in the remove operation is number 1, right? But the top of the stack contains 4, so you have to reorder this. So you have to reorder this in such way that the value will be sorted. So the top value will be 1, then 3, then 4, then 5, right? So these will be removed. Okay, now you can remove from the stack 1. Okay, so this 1 will be removed. Now you are given again an add operation. This is at 2. Now in this case you don't need to reorder if you have a remove operation, because the top of the stack contains 2, right? Again, if you are given again remove operation, then the top of the stack contains 3. You don't need to reorder this again, right? This is contains 4 if the remove operation comes again. So this is the best way you can do reordering process, right? So you can reorder these elements when you need, actually. If you don't need to reorder, you should not do it. Okay, let's see the code. This is the code. You can see, first of all, this is the n number of commands, and this is a stack we need. So this is the answer we will print, and this is the order we have to remove in the remove the box. So first of all, we are processing this we are reading 2 into n commands, 2 n commands. This is the command. If the command is add, then we will receive a value to push a value, right? So then we will simply push into the stack. Then the real things come when the command is not add. This is remove operation. So if a remove operation comes, we will increment the order, right? Initially it was 0, so this is if remove operation comes, we will simply increment the order. uh, this is the number of box we have to remove. Then if the stack is not empty, in this implementation what we are doing is that if the top value stack is not equals order, that means the box we have to remove from the stack, the value of the box is not equals the top of the stack, then if the value is equals, then we can simply pop out this value. But if the value is not equals, then we have to reorder this, right? We have to reorder this in such a way that the value will be sorted. So we will do that in simply that we will remove all the value from the stack. So then it means that if the stack is empty, then we have done a reorder process, right? We have done a reorder. uh, that means the answer will be incremented. Then whenever a remove operation will come, if the stack is empty, then it means that we have already done a reordering, so we don't need any pop-up operations. we don't need to check the top value of the stack is same or not, because we have already done the reorder. The top value will be same, right? So simply we have done that, and then this is the answer we will print. Mm, let's submit the code. Running on test, okay, refresh the page again. Okay, running on test 21, you can see 37, you can see. So this seems to be fine. 47, okay, refresh again and see. 83, you can see. So this will be accepted, right? So this was all for today. Till the next video drops, keep practicing, and thank you for watching.